If you don't already have it in your mind what deepfakes are, just pause this show right now and go do some image search or some YouTube search. In fact, those of you who think you know about deepfakes, if it's been a couple of hours since you checked in on them, well, research is moving fast. Why don't you go Google again as well? Now, it's true, there is definitely an uncanny valley. When I see deepfakes, the best of them, I find that they're often quite difficult to describe exactly why they're wrong. They're just off. And that's the power of the generative adversarial network. The pair of competitive elements, the generator trying to produce these things, and the discriminator doing its best to know what's real and what's fake. Now, GANs are a powerful tool, and not everything about deepfakes is all bad, even though that's the obvious use of it. But an unfortunate side effect of the whole affair is that GANs are under no obligation whatsoever to produce interpretable models. So we live in a world in which seeing is quickly becoming no longer believing, and even our ability to detect fake things is going to diminish with time. The fooling of images is very clear, the fooling of video as well. I think everybody gets it. So I wanted to spend some time today getting into another important category in which machine learning and artificial intelligence is continuing to accelerate the advances: natural language processing. What is it like to fake text? Everyone read the nonsense news article that GPT-2 wrote, the one about the unicorns, after 9 tries to find the most interesting one, and they got it. But we also know GPT-2 is an expensive thing to train. So what's possible and practical to do in terms of faking text? This week on the show, David Adelani joins us to discuss his recent paper, Generating Sentiment-Preserving Fake Online Reviews Using Neural Network Models and Their Human and Machine-Based Detection.
My name is David Adelani. I'm a PhD student at Zalando University. I work with the Spoken Language System Group, where we do research on natural language understanding, like some speech recognition, and mostly natural language processing.
Very cool. Definitely some exciting areas. Do you have a particular focus within that field or a special problem you're tackling?
I'm working mostly on privacy-preserving dialogue systems, but I'm working on the test side. Basically, when you already do speech recognition and you try to remove every private information that is remaining in the speech transcript. So we are focusing on how do we neutralize every privacy sensitive word in speech transcript.
I see a lot of challenges in that. If you don't mind, before we get to the main paper, I'd love to unpack it a little bit more. It would be natural that you could recognize someone saying, okay, my PIN number is 1234, and you know to blank that out. But I imagine there's some trickier problems too. Could you give an example of a really tough situation that's challenging for algorithms?
For example, one really difficult task is the style, the writing style or the speaking style. So there are ways you could kind of add noise to the speech signal in such a way that you are not able to detect the person's voice. But once you get a speech transcript, everything is in the text and you can analyze the style of the writing of the person and you can still detect the person's information. And this doesn't relate to what you can automatically detect, like credit card number or phone number, and you can do some pattern matching to remove them. So these are more difficult tasks.
Well, the main paper I asked you on to discuss is Generating Sentiment-Preserving Fake Online Reviews Using Natural Language Models and Their Human and Machine-Based Detection. So a lot of great stuff that's right in line with what we talk about on Data Skeptic. Maybe we can begin at a high level. Fake reviews are nothing new. What's becoming more interesting or what's changing right now?
Yeah, it's a very known problem. It probably is one of the reasons why Amazon had like verified buyer to their platform. But the big difference we have now is we have very good models that can generate fluent synthetic text that is very difficult to distinguish for humans. And the technology or the neural network models gets better day by day. Like my professor used to say, like, what's the new latest language model this month? So basically, like almost every month you have a better language model coming out. So as the system improves, also the difficulty in distinguishing whether this is real or synthetic, the difficulty is higher.
Well, given the state of the art, when you as a human being read certain reviews, does it pass the imitation game? Can you tell those that are fake and those that are real?
I think this is really difficult. For example, what we observe in our paper is always by random chance. So humans just get lucky. Based on our experiment where we give users 4 reviews and ask them to identify one real review from 4 options, I think the accuracy was around 25%, which means that it's just like a game of chance, random guessing.
Well, what's the point of these fake reviewers? Why are the producers of such things producing them?
Yeah, the reason is that you could use it to influence people's decisions. For example, from the buying decisions of customers, you can use it to increase the profit of an organization, or you can use it to attack your competitors so that they have less customers. So I think also, apart from the review system, you could also use the same technology for politics, for example, on Twitter, and just for political benefit. So where you just try to drive attention of people to your political party or your organization.
And maybe someone who's very cynical might say, oh, who cares about the fake reviews? Let's just assume most reviews are fake and I have to take everything with a really, really big grain of salt. Why do we need a systematic algorithmic approach to help?
I think one big difference is that people are not only influenced by the content of the review, but they're also influenced by the volume, how much of reviews a particular product gets. So this kind of affects the decisions of people. For example, the buying decisions. If a product has like 1,000 reviews on Amazon, oh, you want to trust that not because you have read it or you know whether it's fake or real, and this kind of affect people's decision. And if you take some time to read that, and it's very difficult to read the reviews, and it's difficult to really distinguish whether they are fake or not, actually you will just go for this product. There's a need for automatic way of removing all these fake reviews so that they don't get to the system, so that a user do not use just a volume of the number of reviews to make a decision.
Well, I'd love to get into some of the generating principles. One of the novel things about your work is that it's sentiment preserving. Could you talk a little bit about what that is and how you accomplish it?
So we call it sentiment preserving fake reviews. So fake review generation. The normal way people used to generate reviews is that they just use a language model. Our work is not the first one. We have some papers that have done this in the past. They always do a post-processing step to kind of align the reviews to the right sentiment or to the right topic. So our whole approach is to use a simple method without the need of post-processing to preserve the sentiment of the review. So, and that's a big difference. So in our approach, you are just going to use an example of a positive or a negative review. And based on this example, you can generate more reviews that look like that. So because the language model is a continuation of the previous post or the previous review, so it kind of still preserved the context and also is like a paraphrase of the original review. So they kind of preserve the sentiment. So we don't need to do any post processing.
And could you talk a little bit about, I guess, the mechanics of the generation of these? I think listeners will be aware of like using GPT-2 to make babbling text, but what do you have to do to get specifically the reviews you want?
Our approach is very simple. We collected like Amazon and Yelp reviews and we just concatenate them together. For example, using new line, we fine tune GPT-2. So GPT-2 is a very large model based on the transformer architecture. And the advantage of this model is that it produces very fluent like text and it's easily generalizable to new domains. Also, it's very easy to adapt to new data sets. So because of these very nice properties, what we did is just to fine tune GPT-2 on a large number of Amazon and Yelp reviews. And we did not like do any fancy stuff, just concatenate the reviews and fine tune the models. So fine tuning involves just continue training from where you stopped on a new data set so that you can adapt the parameters of the model. This is how we train the model. And in the generation step, all we have to do is pick an example of a review of a particular sentiment. We just give it to the GPT model as a seed review. So the GPT model now continues generating based on the context of the seed review. And we just say, okay, generate like 3 sentences or generate like 120 words. And based on this, we find a very fluent review like text. which is able to feel human. So the process is very simple. And just because there's no complete guarantee that GPT-2 will preserve the context, even if we think it will. So we have a second step, which is training a classifier to be able to detect whether it preserves the sentiment of the original review or not. If it preserves the sentiment, we can add it to a pool of potential fake reviews to attack a system. If not, we reject such a review.
And what sort of, or how much variation do you see across these generated reviews? If I went and used your methods to, let's say, make 100, would I find that they're redundant by the time I've gotten to the 50th? How creative, I guess, is the system?
I think many of them are relevant. Of course, we didn't check everything. We just glanced through a few. But actually, most of the generated text actually are very fluent. So it is an interesting thing. But maybe not all of them preserve the original context. Maybe not all of them will be able to fool humans. So I would say most of the reviews are used, at least for this attack.
Well, for a human being who wants to be especially discerning, do you have any advice or telltale signs for catching a fake review? What are the ways in which the machine is giving the less preferred examples?
There's a previous work before our work, which is called GLTR. This analyzes the text to know it kind of gives you a distribution of how frequent are the words there in the text. So for humans, we are more diverse than the machine, so we kind of use more rare words, but the machine kind of focuses on very frequent words. So using this approach, if you have this kind of statistical analysis, this GLTR provides a tool like a web platform where you can analyze the text. And actually in their paper, this kind of improves the accuracy of detecting fake text from 54% to over 72%. That's a huge improvement. But our approach, we kind of combine GLTR with OpenAI GPT-2 detector into a fused model, and we kind of benefit by just using an automatic, like a completely machine learning way of detecting fake review and also just analyzing the statistical property of the text to decide on if something is fake or not. So if you can have a system that provides some kind of information just to guide the user, I think it will make it very easy for humans to detect.
So I have personally tried not to read too many reviews. I will look at the average rating as you were suggesting, or at least of the sites I'm visiting. Maybe it's a personal problem, but the reviews tend to be poorly written, really bad grammar. Sometimes I even think they're a bot, and then maybe I'll go to a profile and be like, oh no, this person is just very sloppy in how they write. How much does the content of the reviews themselves, given that they're not from professional journalists, anybody can type in anything, what sort of impact does that have on your project?
Actually, but this is not completely true. There are some previous work, for example, even with the large GPT-2 model. For this experiment, we use the smallest model. For the large model, at least in their reports, what they discovered is if you train your model on journalistic articles, for example, on New York Times, like kind of articles, and you give it to users and say, can you distinguish? They can still not distinguish. And actually, people they kind of think most of the time, in their paper, they reported like 75% of the time, they think a fake news is real. And the reason why they're thinking about this is because they just look at the text and say, is this plausible? Can I believe this article? They do not really think about, is this accurate? Can a human being write like this? But they just kind of analyze the story and say, this is a plausible story. So even if it's a standard text from Wikipedia or by a journalist, I think it's still not a complete guarantee that you can detect the text.
Thanks to this week's sponsor, Brilliant. Brilliant is an interactive learning tool that I like very much, and I think you will too. If you head over to brilliant.org/dataskeptic, I actually recommend that. Do that now. Pull up, there's a great video there that walks you through some of the stuff they have, showing me this algebra test and some fun ways that people can build programs in the browser. This looks like good stuff I might be able to get my nephew into. I didn't know they had fun stuff like that. I'm used to going down and doing these courses or doing the problem of the day. I have a policy called leave a tab open for Brilliant. Just sit there and I need a little coffee break type thing. The courses are divided up into nice sections to do that. In particular, I've been going through the group theory course here on the stay-at-home order. There's an interesting interesting group theory problem that's a pretty advanced thing I want to get into, and having this course has been really helpful for prepping up for that battle. So I'm grateful to Brilliant, and I think you guys should check it out as well. Head over to brilliant.org/dataskeptic so they know we sent you. Once again, brilliant.org/dataskeptic. Yeah, I feel like reviews in particular are, I certainly wouldn't say low-hanging fruit, but the idea that we're at human level accuracy for faking reviews is not too surprising because it's, at least in my mind, I feel free to disagree, but it's an easier thing to fake a review than, let's say, fake a news story where the facts have to be consistent, there has to be a point. The review could just be frustration, and sometimes that's what it is. With that in mind, I guess, is there a way of measuring where we are in the state of the art? Will there come a day when no algorithm can detect fake from real, or what's the course forward look like, do you think?
I think we're in the right direction. So the algorithms are getting smarter by the day in detecting fake news or fake reviews. But humans, don't let me say I give up on the humans now, but there's still more opportunity from the algorithm level. And I think in the next few years, we'll be able to get something that is very good in detecting fake news reviews. But actually, fake reviews are more difficult to detect than fake news, just because the reviews are short and also you have less statistical power based on the length of the text. So currently, some state-of-the-art kind of reports 95% accuracy in detecting fake news. And for fake reviews, it's much lower, even less than 90%. But there's a very large way of improving this detection, algorithm level, even more than the human detection.
You had also earlier pointed out this fact that Amazon has a verified buyer aspect of their reviews, and there are probably a dozen things we could brainstorm about of ways other than language to look into this, other metadata. I guess, what do you think long-term will be the contribution of natural language understanding to the fighting of fake reviews? Is it going to come down to 50% certification and reputation and 50% language, or where will the contributing detection facilities lie?
I would say it's a combination of analyzing the content and also the metadata, and for example also to the credibility of the system or the user providing this information. So it will be kind of a combination of like these three factors, because just using one of them, it's not enough.
Well, there's one table I'll refer listeners to. It's table 2 in the paper that gives 3 examples of reviews: a real one, a fake one with pre-trained GPT-2, and one with your fine-tuned GPT-2 model. And I did a little experiment. Well, I guess technically it's not an experiment because it was very informal, but showed a couple friends and coworkers these reviews and said, I took off the label, said, which of these 3 do you think are real and fake? People identified the second one, although I randomized it, but that was the pre-trained GPT-2. They eliminated that one. But people struggle to tell the difference between your fine-tuned model and the original review. Did you have a similar experience, or do you have a way of doing some empirical measurement about how often you were able to fake people out?
Yes, we did that. I mean, so that's the result of our analysis. I think this would be in table 5 and table 6. So we actually performed the same experiment where, or something similar, where we gave people 4 reviews and asked them to select one real review. And that is the result in table 6.
And could you broadly summarize that? What methods are performing well?
In general, we find that people really find it more difficult to detect the fine-tuned GPT-2 than the pre-trained GPT-2. So at least in the case of the Amazon, of course, the result is not completely true for the Yelp review. But for the Amazon, the fine-tuned GPT-2 is more difficult for people to detect. And this applies to both native speakers and non-native. So for the native speakers, their detection is better than non-native speaker. For example, in the fine-tuned GPT-2, the native speaker were able to detect it almost 29%, and while non-native speaker was around 24%. So there's a kind of 4% difference whether they are native or non-native, because the native speaker, maybe they could detect, they have more information about why this should not be a human versus a machine. So, but the difference is actually not big across all the models. So, but one thing that is consistent is that fine-tuned GPT-2 is always better. It's more review-like and more convincing than pre-trained GPT-2.
Very intuitive, I would say. That one would hope that that would be true. That's the point of the fine tuning. With that in mind, one way to characterize this is to say that part of the achievement of your fake reviews is standing on the shoulders of GPT-2, and part of it is the fine tuning you guys implemented. Looking forward, both those things will continue in research, I'm sure. We're going to see bigger and better language models and bigger and better fine tunings. Where do you think most NLU practitioners are going to find the most value in chasing those big models or in doing some fine tuning of their own?
Most people will do more fine tuning or adapting the large language models because they're very difficult to train. It involves a lot of data, and I think this can only be done by large companies. So fine tuning is cheap. You can run few airbox that will give you very good accuracy in a short time. I would think most people will make use of fine tuning option. A second area of research that is mostly interesting to other people is how to distill this model. So how can you make these large models smaller without a significant drop in the performance of this model? And there's a lot of work in this direction from the distilled, but there's another one from Microsoft recently, which is the distilled XLM model, and there's a distilled GPT-2 model by Organ Face. So people are really interested, and with a lot of interest in how can we have a greener AI, people just want to train this large model once, and other people adapt it to their task.
There's the famous news article I think most people will know of that GPT-2 wrote some time ago about studying unicorns in South America or something like that, and it goes on for quite some time. And what I think not everyone realizes, although not that it's hidden, it's up there in the fine print, the production of this unicorn news article, I think they took like 9 attempts to generate something random, and they picked the most intriguing one, which, no surprise, it was a really good example, but it glosses over, well, you rolled the dice 9 times. I'm seeing a sort of analogy between that and your architecture in which your model produces these, and then you have this BERT text classifier after the fact going through and kind of automating that process. Is that a fair analogy in those two approaches?
It's a fair analogy, and I think there's always a big difference in performance whether you have like a seed text or not. So if GPT-2 guys just generate text from the language model without providing it like a seed example, this kind of impact what will be how fluent or useful the output of the language model is. And I think they tried both. In their experiment and in-house, if you provide it with a good seed, then you can really generate very good text. So one of the reasons why our approach is very good, don't let me say very good, but produces more fluent fake reviews is because we provide a complete example of a real review as a seed. So this provides a very rich context for the language model to generate like a paraphrase or like a very good continuation of that review.
What would you say to someone who might look at this paper and raise some ethical concern that you've produced the blueprint for fraudulent people to go make better fake reviews?
Yeah, actually, this is a very interesting point. I really thought of this and I was a bit skeptical about, oh, do I need to really publish this paper? Because I don't want to add more problems. The world has a lot of problems. But the focus of this paper is not just producing this fake, because if we don't do it, someone is going to do it. And it's just, I won't say to an adversary, this is just a natural way of thinking. What can I do with this model? So because even from the producers of GPT-2, they started thinking of two directions. What are the benefits? What are the positive aspects? What are the negative aspects? And this is one of the reasons why they delayed in like releasing all their models. So the largest model took like more than 6 or 9 months to release the model. They actually released the model when they were able to release a detection method. So in our own, we are not just presenting a way just to generate. So the story did not end about generating all this sentiment preserving fake review. We ended the story with how do we automatically detect this because humans cannot do this. Of course, we noted that this is more difficult for short text like reviews, but this is possible for the algorithm, and we should do more research on this. So the focus is on detection, not just on generation.
Definitely, yeah. And having a discussion of generation alone promotes the consciousness about these methods and gets people thinking about detection, I think, as well. Well, given that you've been looking at corpora of this data and I presume engaging in commerce, you must go to websites and things to buy stuff. Has this work changed the way you perceive the value of reviews?
Yes, of course. Then, for example, if I now go to Amazon to buy that I want to buy a product, I'm looking for verified buyer just because I know, okay, at least this person bought this. I can trust this review more. But I'm also still affected by volume of the number of reviews. And I think this is a harder problem. So I did a work on the past on how the volume of feedback that people receive kind of affect their behavior. And this is actually true. The volume of the reviews can still sway bias to make some decisions. So even if, in my case, I will not pay so much attention to the content of the review, but the volume still affect me. And I think it does affect many people.
Yeah, I find it hard not to myself, yeah, but something we've got to be cognizant of. Well, how do you get started on a project like this?
When I resumed my internship, the idea was to work on adversarial text generation, on how you can modify some of the content of the text in such a way that it's going to fool a classifier. For example, you can add more punctuations or kind of rearrange characters of a text in a way, and this kind of influence or kind of bring down the performance of your classifier, text classification systems. So we started with this project, and after that, we found out that there was a lot of popularity about the GPT models. So I started my internship in January, and that was the period also where there was a lot of like information or media posts about GPT-2. So then we found that maybe this is a better project to work on than what I initially was looking into. And that's how we went into this. The interesting thing is that around that period, we also have another large language model, which is called BERT. This is a Max language model. So it's not very good with generation, but it's better for feature engineering. And also, if you fine tune it on most NLP tasks, it gives better performance. So we kind of like combine these two language models and try to do something interesting with it.
And what's next along this line of research? I'm sure there's more to do here. What are some of the interesting areas you hope to work on in the future?
Actually, I'm not working on this area now. I'm doing more privacy now.
Well, I suspect there's some overlap in a way.
Yeah, there's some overlap and slightly different problem. This is more degenerating sentiment preserving fake review. It's more like a security problem. And the other one is privacy problem, which is you want to hide the information of users. You don't want them to be misused. So in a way, they kind of overlap, and in a way, they are also different.
Well, David, I'll have to invite you back on to talk about privacy-preserving stuff. I think that's an interesting and topic of growing importance for sure.
Yeah, I hope I can have a good paper on that too.
All right, well, I'll be keeping my eyes out for that, and you'll get my email. Because for me personally, if nothing else, the ability to do that well and to say, hey, now we can take some corpus of documents where there's a concern of privacy and remove that, de-anonymize it, all those things, opens up a lot of training data. So for that and many reasons, I wish you well on those endeavors. Excellent. Well, David, lastly, is there any way people can follow you online?
Yeah, so you can search for my name on Twitter. David Ifeoluwa Adelani.
Yeah, check the show notes, but it'll be there as well.
Thank you for inviting me. I was really surprised when I saw this email.
Yeah, well, I'm glad Unicode is supported there and you're able to do it. So I'll refer people to the link in the show notes. That'll be maybe the best way to get there the fastest. Awesome. Well, thanks again, David. Thanks for listening to Data Skeptic Interpretability. Our guest this week was David Adelani. Our theme song is Number 5 by Big D and the Kids Table. Claudia Armbruster is our associate producer. Guest coordination by Vanessa Burciaga. I'm your host, Kyle Polich. Stay skeptical of everything you read, see or otherwise. Catch you guys next time.
What